Hey guys, here we go. We're going to do Unit 2, Video 4, Part A. This part, I have to go through some concept with you, but I'm going to focus on third power because odd-powered things are easier. So we're going to start here. So I have to go through some background so that this whole big concept makes sense. Let me put it this way. Mathematically, there are many things I can show you how to do quickly and easily. This is one of those things that's not hard to do, but if you don't get the concept, which is not so easy to get sometimes, because when it comes to, algebra, the problem is there's a lot of stuff that's I'm running out of room. Abstract. So in algebra, you sometimes, the actual stuff you have to do is not that difficult, but understanding why it works or what it does is kind of weird. So I'm going to erase this, get this out of the way. But I wanted to definitely, come on, start you off with this slow but sure. So I did this in two parts. So here we go. You guys know there is such a thing out there as a parent function for a cubed graph. And we did this day one. That guy, that cube thing right there, that's parent function I asked you to memorize. This guy next to it, the cube root function, is not one that I asked you to memorize yet. But as we go through this trimester, you're going to see more parent functions pop out at you. So here we go. This guy, the cube root, looks like this. And I got to tell you, I like to draw it in two pieces because I'm not a great artist. So I draw it like half of the curve. Whoops, oh my gosh. It's supposed to be a curve, so that's not going to do. Half of the curve goes like this. The other half like this. That's a cube root graph. Okay? If you can draw that nice and clean and pretty without picking up your pen or pencil, more power to you. Good for you. I can't. Now, here's what I want to do with this. Let's call this one over here, let's call this guy f of x. Let's be more descriptive. And what I'm about to show you is these two dudes are inverses of each other. So I'm just going to be so bold as to tell you this guy's name is f of x, this guy's name is f inverse x. Then we're going to do a little bit of algebraic checking on this. So I'm going to say, what would happen if I took the composite of this function with this one? So what am I doing? I'm going to be plugging in, I got to give myself some room. I'm going to be plugging in the cube root of x into the other guy. And what does the other guy do for a living? What does this guy do for a living? It takes whatever you give it, and it cubes it. So if you cube a cube root, the result is x. Same thing goes on the other side. If I did what is f inverse of f of x, remember that's called a composite function, then what you're doing is you're taking the cube guy, I'm going to take this dude, and I'm going to plug it into the other. So what does f inverse do for a living? It says whatever you give me, I'm going to take the cube root of it. Remember, a cube root is kind of like a square root. It's like what times itself 3 times. That's what it's asking. We'll give you, x cubed. And the answer, of course, here would then be x. So when you do f of g of x and g of f of x, it doesn't always equal the same thing. But when two functions are inverses, it does. If f of f inverse of whatever the function is, if that is the same thing as this, then you know two functions are inverses of each other. And even better, if you do this, I know I said do, you'll get x, and if you do this, you'll get x. But I don't want to focus on the algebraic check for this stuff. I don't. What I want you guys to do is embrace that we have a way to check things graphically. Now, I do not want you to grab your graphing calculator for this because number one, this is really good practice. It's a skill that's going to pop up again and again. So, hey, I only have 12 weeks to go through this with you guys. So I need you to really just trust me and practice things when they happen. Could you do this on a graphing calculator? Yes, you could. But there's a couple drawbacks and a couple hang-ups that you're going to run into if you try it. And I don't want to share what those problems are going to be yet because I want you to do it my way and practice. So here's what I mean by that. I know that if I want to check to see if two functions are inverses of each other, come on, snap straight, there we go, then I can graph both of them on the same coordinate system. So here we go. Right through the middle here, I'm going to draw my cube function. Now remember, this is just a rough sketch. This is not perfect. I'm going to draw my cube root function. Check this out. I'm going to draw my cube root function. Ooh, I did that in one shot. And then I'm going to draw the line, whoop, y equals x. Oh, God, that was horrible. Sorry. And you know what? I'm going to try and do that just one more time. Make it a little better. I'm going to try and draw the line y equals x. That was way better. And do you see what happened there? The line y equals x splits my image down the middle. Now, I could do this on a graphing calculator. I could, on a graphing calculator, go to y1 and plug in this. I could go to y2 on my graphing calculator and plug in this. I could go to y3 on my graphing calculator, plug in that, and I would get basically this picture. Except where some of you are not going to know where to find this guy, and I'm not going to tell you yet. If you really want to do it that way, you're not paying attention to what I'm trying to show you. But anyway, if you're patient enough, I'll show you where that button is eventually. Here we go. I want to get going then with a couple examples. So not every function I'm going to give you is going to look like that. So let's begin with this guy. I'm going to write out every step, by the way. Now, I'm going to give you this example here. I'm going to say, here's a function. That's a function that I know how to sketch the graph of. I totally do. But I want you to find its inverse and check it graphically. So the object of the game is find the inverse. And then the second object of the game is check it by graphing. Oh crap, I'm running out of room. Graphing. Kind of squeeze that in. So first things first, how do I find an inverse? No matter what it is, I write it in y equals form. I do. Then I interchange where the x and the y are. I don't interchange anything else. I interchange where the x and the y are. And then I get y by itself. So if I'm going to get y by itself, I would take away 4. And I would end up with, on this side, x minus 4 is equal to y minus 2 cubed. Now, to get rid of a cube, we cube root it. So I would go over here and I would say, to get rid of this, I'm going to take the cube root of that side. If I do that, cube root of something cubed, I get whatever's there. I get the creamy filling. Yum, there it is. But that means I'd have to do the same thing to this side to keep it equal. And if I do that, that's fine. I'm just keeping track of my work. I'll call it cube root of x minus 4. But you'll see my y is not by itself yet. I would have to add 2 to this side. I'd have to add 2 to that side. At which point I would have the cube root of x minus 4 plus 2 is equal to y. Now, this looks always weird to me because I don't say stuff equals y. I say y equals stuff. But you know what? It doesn't matter which side the y is on. If this thing equals this stuff, they're equal. But remember, we're going to rewrite our thing in inverse notation. So that's why I'm kind of making a point of this. I am now going to say, hey, the original function was called g. So I'm going to call the answer g inverse. And now I'm just going to make it beautiful anyway. And then Shazam. That's my answer. I'm going to check this thing graphically. Now, if I did this right, if I did every step correctly, then when I graph these two guys, they should be mirror images. Come on, there we go. Come on, here we go. So let's begin. We know how to graph this. This was the very first lesson we went through. I have to go 2 units to the right. I have to go up 4 units. That would be the dot in the middle of my third power graph. Then I'm going to go down here and I go, you know what? Every single function obeys the exact same rules of motion. So based on that, I already know what the parent function of this guy looks like. So I am going to go, what, 4 units to the right, 2 units up, and I already have that. I'm going to sketch this. Guys, I got to do this in 2 parts. I'm such a crappy artist. And then when I draw my line y equals x to split it down the middle, voila, I have this mirror image beautiful look to this. Now, granted, this is a rough sketch. I could have done a little bit better. I could have. Let me take it away and try again, just so it looks a little bit better. If I drew my picture just a little bit better, that looks a little bit more like a mirror image to me. Remember, if you were to fold this graph over that line, you'd get the same picture on both sides. That is a visual check that I did my work correctly. When you guys get to the assignment, I'm going to give you a function. Oh, come on. Oh, really? Come on. I'm going to give you a function. I'm going to ask you to show me your work. So you give me the inverse. And then I'm going to say sketch the graph of the function, its inverse, and the line y equals x. That's what I'm going to ask you for. Okay. Now, here is something new in my second example. So let me change colors here. I'm going to go to my second example. This is example 2. And the original problem that they give me in this example, they're going to call it h of x, and then it's this dude, negative cube root x plus 2. That's my original function. So when I finally do get to the very end of this, my answer is going to be called h inverse. And since the original function is a cube root, my inverse is going to be a cubic. Cubic. C-U-B-I-C. Cubic. Third power. Let's begin. I'm going to say if I called this guy y, I could do this. Now, some of you guys are into cutting some corners on me, and you'd like to just, well, I could do this part. I don't need to write this step, do I? Man, you know what's funny about inverses is you will find so many patterns and so many things that you can do to cut corners. But if you're wrong and I got nothing to grade, you're going to get so dinged. The more work you show me, the better off you are on a test, so you should practice the way you want to perform. So my thing is show the work. I'm going to move the 2 to the other side. Now, I want to do something. I want to be a little bit bold. What do I have on the left-hand side? What do I have on the left-hand side? I have x minus 2. That's what I have. What do I have on the right-hand side? I have a negative cube root y. See what I did there? I just flip-flopped where the two items are because my next move is this. I need to get the y by itself. I cannot cube both sides yet. I got to get this negative out of the way. Now this negative technically counts as being like a little -1 sitting here. So guess what? I'm going to divide both sides by -1. I am. Over here it all cancels out, and I'm going to go back to a different black pen. Oh, come on, there we go. And I'm going to say, ha ha ha, this is a cube root of y equals. Now I told you guys this, get in good habits. Get in good habits early. I do not want to write this as this ugly fraction with a -1 on the bottom. I don't. So I could either say numerator divided by negative number, that's a negative thing. Or I could run the negative through the top and make the top part negative and the bottom part positive. If the bottom part was positive, I wouldn't even have to write it. It's a 1. So get in this great habit, which is take the negative value and run it through the top. When you run it through the top, it does not just hit the first term. It hits both terms. When you take a negative and you run it through the top, negative hits everything in the top. Let that sink into your brain. Maybe take that down as your notes. So here we go. What does it look like on this side then? -x plus 2. That's what it looks like. Now, I'm going to take this entire side and I'm going to cube it. That means I'm going to take this entire side and I'm going to cube it. That negative is inside the parentheses, not outside. And I get y equals. Now, -x plus 2 cubed. Beautiful. That is exactly what it's supposed to look like. It totally is. However, I want you to know that whenever this guy is like -x plus 2, it is very, very common for the book that you're working on to rewrite it this way. They'll do it this way. They'll say 2 minus x cubed. These guys are equivalent statements, but I wanted to make sure you saw that. And then what would I call this thing? H inverse x. Okay? This and this are technically the exact same thing. But remember, I want you to know there's my original way up here. There's my original. This guy's the inverse of that. And this looks kind of backwards weird. And what do I do with the negative on the x? See, this lesson, I have to give you guys some heads up on some things. If you have a negative on the variable, a negative on the variable, and this will happen again to us in our future, you're going to see it. What that is a sideways flip. What? Sideways flip? What do you mean by that? Okay, check this out. We are going to finish this problem, but I want to show you what a sideways flip does for you here. But when we do come back, remember, I want you to find the inverse, then I want you to come back and graph it and check it. So I still haven't checked it yet, but let me show you about a sideways flip. I'm going to come down here a little bit. So here we go. If I have this function here, and I'm telling you, the negative's on the variable, it's going to be a sideways flip. Here's the thing about a cubic. If you take a cube function All right, now watch this. I'm going to use different colors. If you take a cubic function and flip it sideways, whoa, I don't know what the heck I did there at all. I hope, oh good, okay, I hit something weird. If you flip it sideways, everything that's over here is going to go over there. Everything that's over here is going to go over there. So if you flip it sideways, it looks like this when you flip it. That's a sideways flip. Now, pay attention, because I'm going to change colors one more time. Let's do green. If I did graph something with a negative on the function, if the negative is out front, that means it's a top to bottom flip. Okay, a negative on the variable is a sideways flip. Negative, I'm going to write this in green, negative on the function, or the actual outskirts, on the outside of the parentheses. That's what a negative on the function means, outside the parentheses. It's a top to bottom flip. Now, we have already done top to bottom flips, but watch. If I took the original and I said, let's flip it top to bottom, then what's up would be down, what's down would be up, and that would mean this guy. And what I want you to see from this is when it comes to a cube function or a cube root function, odd. When it's got that odd thing going for it, that's the key. Odd power, odd root. A sideways flip and a top to bottom flip will end up in the same spot. It's the easiest one to flip because you can't get it wrong. Okay? So, let's go back. I want to finish this problem. Let me show you. We're going to do it one more time, and guess what? You can pause this. You can rewatch this as many times as you want. So, you know what? Let's do the, here's my original. I'm going to go back to black. What? What the heck happened there? No, back to black. Thank you. So here we go. If I graph this function here, it doesn't have a sideways motion. There is absolutely no sideways motion, but it says go up 2 units. If I go up 2 units, my original graph would be a cube root, so that would be my original. But it's got a negative on the function. It's got a negative on the function, which means a top to bottom flip, which means everything that is up is down, everything down is up. So I'm going to use a different color. So instead of up, this guy would go down. Instead of down, this guy would go up. There's my flipped guy. So that's what this dude over here, h of x, would look like. I am going to now get rid of that guy, that guide graph I used. Let's go back to black, because I got to do a, come on. Now I'm going to graph this dude. So here's the thing. I tried to warn you about this a while ago. If it's inside parentheses, it's always lateral motion. If it's inside parentheses, it's always lateral. See how this guy up here is not inside parentheses, so he's up or down. But lateral motion is always inside parentheses, and how do you know which way it's going? You set it equal to 0 in your head. So, what magic number would I have to put here to make the inside of that parentheses 0? The answer would be 2. So I'm going to go 1, 2 units to the right. That's what I am going to do. So, let's take a look at what this guy is going to look like, grand total. I am going to mark it with a 2 right here. It's a cube function, so a cube function normally goes like this. I'm about to erase this, so don't freak out. It normally goes like that. It does. However, this guy has been sideways flipped. Well, if you flip this thing sideways, this part's going over here. Whoops. Oh my God. I don't know how that happened. That part's going over there. The bottom part's going over here. So I'm going to use a different color. Let's go blue again. And I'm going to flip it. So it's going to look like this. It's going to come down through my point and then go like that. Now let me get rid of this black guide graph. I just use that to guide me. And then I'm going to take a black pen and sketch in my y equals x. Oh God, it didn't straighten up. Okay, anyway. These guys should have all intersected right here, but guess what? I am not an artist. I am trying my best to hand sketch this, but it's really good practice. And guess what? We're talking about lateral, we're talking about sideways flipping, etc. We have a lot of information in here, but you know what? It's good practice all the way around for us. I have, let me see, I think I have two more examples for this lesson. So here's what I want to do. I'm going to go down, I'm going to call this guy example 3. And I am going to say, here's the original problem, f of x equals. And I have a negative x minus 4 cubed plus 1. So I have to find the inverse for this thing. So of course, I'm going to show you every step. I don't want to lose anybody in my moves here. So I'm going to say y equals negative x minus 4 cubed plus 1. Then I'm going to interchange where these guys are. I'm going to put the x here. I'm going to say y minus 4 cubed plus 1. I am now going to move the 1 to the other side. I got x minus 1 equals negative y minus 4 cubed. Remember, my job is to get y by itself, so currently I have this dude in the way. There's a negative out here. I don't want that negative there. So I divide both sides by negative 1. And we saw this in the other one. Going to cancel there. And I'm going to, whoop, oh, come on, please. There we go. I'm going to run that negative through the top. So if you want to try and do that ahead of me, try it. You can pause it. Here we go. Running the negative through, it's going to look like that then, which equals y minus 4 quantity cubed. I am then going to cube root this. I am going to cube root this, which will then give me the cube root of negative x plus 1 equals y minus 4. I'm going to get y by itself because I'm almost home free. I've got to move the 4 over. I'm going to finish my work up over here because I'm running out of room. So for example, here I got y equals, what's the other side going to look like? It's going to look like the cube root of negative x plus 1 with a plus 4 on the outside. Now, like I said, a lot of books will write this answer, number 1, since they started me with f of x, they're going to call this answer f inverse x. And then they're going to do this inside the root. They're going to do 1 minus x. I don't know why they do that, but they do a lot of the time. I don't know, I guess it looks a little more streamlined, but the thing is, what I want you to realize is, this is going to be a sideways flip. This will cause my graph to flip sideways because the negative is on the variable. Okay, but just like I showed you earlier, whether you flip a cube root sideways or top to bottom, it'll still look the same after you flip it. It's a weird phenomenon with the cube or cubic odd type of functions. So here's my guy. I have an inverse, I have an original, I can sketch those graphs. I'm going to put it right here. Here we go. So I'm going to straighten it up. There we go. Straighten it up. Looking good. Let's graph the first one, the original. Now, if I graph the original function, I'm going to go 1, 2, 3, 4 units to the right. That's sideways motion. I'm going to go up 1. And now I'm going to draw a cube graph, right? But I got to flip it top to bottom style. So I don't want the graph I just sketched in extremely graphily. Here, let's use red this time. Red. I would then, what is it going to look like? It's going to look more like that. That's what it's going to look like. So I'm going to get rid of this guide. I'm going to get rid of that. That was just there to mentally help me see what's going on. Now, I could graph this guy next. Oh, crud, I forgot I had the eraser on. Okay, I'm going back to black. I could graph this guy next. I totally could. But I could also graph y equals x next. Now, let me show you a trick. I'm going to graph this guy next because it'll help me see if I'm correct when I sketch this one in. So I'm going to go back to what would be my sideways motion. Set this equal to 0 in your mind. 1 minus x equals 0. What would x have to be? It would have to be positive 1. So this is 1 unit to the right. This is up 4. So I go 1 unit, 1, 2, 3, 4. So I've got this guy, but I've got not this graph, not this guy. I've got the sideways flip version of this thing. So I'm going to go grab my red pen again. Really? Come on, iPad. And what's going to be on the right-hand side will now be on the left-hand side. What's on the left-hand side will now be on the right-hand side. I'm going to get rid of this black guide graph that I drew. And look at how pretty that is. And I'm not even a great artist, and I think that's got some beauty to it. You know, and they all, well, I forgot what I just, okay. I forgot I had the eraser turned on. Look at that. And they all meet in the middle. That's where they're supposed to, you know, pretty. That's just darn tootin' pretty. And you can check your work because you already know from lesson 1, day 1, how to sketch a function knowing its parent. This is a little bit more. We're adding a little bit more each time, but that's the beauty of math. Once you got something, you can build on it. Okay, I have one more example that I want to show you guys because this is why I broke this into 2 videos. Because I've already shown you a lot of stuff. So here is my last example. What the heck? I decided I would call it example 4. And example 4 looks like this. Y equals the square root of x plus 1 minus 3. Yes, you heard me right. I said square root. So here's the deal. I can still find the inverse for this thing super easy. I can. Look, I'm going to switch the x and the y. Watch, watch. We're almost done. And then I'm going to solve again for y. So I'm going to add 3 to both sides. And I'm going to say, hey, x plus 3, you are equal to the square root of y plus 1. I am going to square both sides. Because if I square a square root, I get rid of it. That means I have to square this thing, so it is now a quantity squared. I'm going to take this 1 and get it over here. And I'm going to rewrite my answer in this form. Y equals x plus 3 squared minus 1. So here's my original. Here is my inverse. Okay? You with me? Now, mathematically, sometimes I show you how to do something one way. Mathematically, I show you how to do something another way. Because down the road, if you master both ways, you get to decide which one is easier. You do. But in the meantime, I'm going to make the decision for you. I am going to tell you, hey, I want you to check this by graphing it. And this is the other reason why I do not want you to grab your graphing calculator. Because graphing calculators do not know how to think. They only know how to spit out what you give them. So this is where your graphing calculator works against you, and I'm going to show it to you right now. Let's graph the original. I'm going to go here and I'm going to say, hey, original function, you are not a cube root, you are a square root. I wonder why Mr. Bogey said, I don't want to do anything square root yet. Well, here's why. And then this is going to come to a screeching halt, and we're going to start on part B. This guy says, move me left 1, down 3. Left 1, down 3. Put a dot. This is a square root graph, so it goes like this. It's just a graceful arc. That's what it looks like. That's a parent function sketch. This guy right here, though, is a parabolic one. And it's going to go left 3, down 1. Left 3, down 1. So I'm going to go left 3, down 1, put a dot. And then I'm going to go like this. Watch. Hey, I'm going to graph this side of my parabola. Hey, you know what? If I drew a line y equals x right now, wouldn't that be pretty? Because they're mirror images of each other? They are mirror images of each other. But wait, this is a parabola, so there's this part. Well, crap. Now it doesn't look the same. This side does not look the same as this side. It's not a mirror image anymore. What do we do? What do we do? Well, here's one thing, and then I'm going to stop. Here's one thing we could do. Whoops, I don't know. Here we go. I have, let's call this guy right here, just for kicks, let's just call this guy f of x. I'm going to call this guy f of x, just for kicks, because function notation, I could do that. But I know that these two dudes are inverses, so I'm going to call this guy up here, I'm going to call this guy f inverse of x. So I'm going to say f inverse of x would be, oh crap, I forgot what it was, x plus 1 minus 3. Now, let's make sure I did that right. Yes, I did. All right, so here we go. If I wanted to not have to graph this to check it, I could do this. I could. I'm going to take this guy and I'm going to plug it into this guy. What would that look like? Well, f would say then, you're going to have the rad x plus 1. Oh, wait a minute. Did I write that down wrong? Oh, yeah, plus 1 minus 3. I'm going to take that whole thing, plus 3, square it. See, this whole chunk replaces the x. Minus 1. Minus 1. It does minus 1 at the end. Well, 3 take away 3, that cancels. Then I'm left with square root of x plus 1 squared, minus 1. If I square a square root, I get the creamy filling. Minus 1, well, 1 take away 1. What do I end up with? X. If two functions are inverses of each other, if you compose them, your answer should be x. So sometimes doing this check, this is called an algebraic check. Sometimes doing an algebraic check is easier than graphing it. Especially when your graph is messed up. What's up with this? What do we do? Well, we realize that this lesson is already 40 minutes long. And we say, you know what? Let's go and we'll look at Unit 2, Video 4, Part B. Let's do that. Okay. Bye, guys.